Hello everyone. This is Jay Ganesh from second year AML department, and I am here to explain about the topic implementation of HMM, that is hidden Markov model. The topics which we are going to cover is what is hidden Markov model, objective, algorithm, Python code implementation, output, applications, and conclusion. First, what is hidden Markov model? A hidden Markov model is a statistical model that can be used to describe the evolution of observable events that depend on internal factors which are not directly observable. We call the observed event a symbol and the invisible factor underlying the observation a state. In applying it, a sequence is modeled as an output of a discrete stochastic process which progresses through a series of states that are hidden from the observer. Objective. The objective is to construct a Python code to find the sequence of hidden states by the known sequence of observances using hidden Markov model. Consider two hidden states, sunny and rainy, with observable states, happy and sad. Algorithm. There are totally 9 steps to be followed. The first step is define the transition matrix, which specifies the probability of transitioning from one hidden state to another. Step 2. Define the emission matrix, which specifies the probability of observing each possible observation given each hidden state. Define the initial probabilities, which specify the probability of starting in each possible hidden state. Step 4. Define the observed sequence, which is the sequence of observations need to be analyzed. Step 5. Initialize the alpha matrix with zeros, where each row represents a time step and each column represents a possible hidden state. Step 6. Calculate the first row of the alpha matrix by multiplying the initial probabilities by the emission probabilities for the first observation. Step 7. Loop through the rest of the observed sequence and calculate the rest of the alpha matrix by multiplying the emission probabilities by the sum of the product of the previous row of the alpha matrix and corresponding row of the transition matrix. Step 8. Calculate the probability of the observed sequence by summing the last row of the matrix. The final step is find the most the final step is find the most likely sequence of hidden states by selecting the hidden state with highest probability at each time step based on the alpha matrix. Let us see the Python code implementation. First, we define the transition matrix, which represents the probabilities of transitioning from one state to another state in a Markov chain. Then, we define the emission matrix, which represents the probabilities of observing a certain weather state, sunny or rainy, given a hidden state in an HMO. Next, we define the initial probabilities, which represent our belief about starting in each possible weather state. We then initialize an alpha matrix with zeros, where each row represents a time step and each column represents a possible weather state. This matrix will be used to store intermediate values for calculating the probability of the observed sequence. Next, we calculate the first row of alpha by multiplying our initial probabilities with their corresponding emission probabilities based on our observed sequence at time step 0. This gives us our initial belief being in each possible weather state at time step 0. Then, using nested loops, we iterate through all remaining time steps and update our beliefs about being in each possible weather state by taking into account both emission and transition probabilities. At each time step t, for every possible current weather state j, we multiply its corresponding emission probability based on our observed sequence at the time step with its previous beliefs, multiplied by its corresponding transition probability from any previous hidden states to this current hidden state. We then sum up these values across all previous hidden states to get updated beliefs for all possible current hidden states at that particular time step t. After iterating through all time steps and updating our beliefs accordingly, we can now calculate the total probability of observing this specific sequence by summing up all final values in alpha at least time step t. Finally, using the updated beliefs stored in alpha matrix throughout the iterations over different time steps along with. This is the output for the following Python code implementation. The most likely sequence of the weather states is sunny, 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 rainy, rainy, sunny. Applications. The first application of the HMM is the speech recognition. HMMs are widely used in speech recognition systems to model the relationship between the acoustic signals and phenomena. Fault diagnosis. HMMs can be employed for fault diagnosis in systems where observations or sensor measurements and hidden states represent different fault modes. Mission translation. In mission translation. In mission translation systems, HMMs can be used to align words between the source and target languages by treating the source and target words as observed and hidden states respectively. Gesture recognition. HMMs are used in gesture recognition systems where observations are sequences of image frames or motion data and hidden states represent different gestures. Weather prediction. HMMs can be applied to model weather phenomena where observed weather data, example temperature, humidity, are influenced by hidden weather states, example sunny, rainy, cloudy. Conclusion. The implementation of hidden Markov model spans diverse fields including speech recognition, bioinformatics, finance, and robotics. Their ability to model sequential data and infer underlying states makes them invaluable tools for tasks ranging from pattern recognition to predictive modeling, contributing significantly to advancements across various domains. And thank you. Have a nice day.